G'day. Welcome to Crystal Clear Mathematics, where it is easier than you think. I'm Graham Henderson, and we still continue our series of videos about hyperbolae and asymptotes. Now, we're going to move away strictly from the kind of graph that we call hyperbolae, and just concentrate on the concept of asymptotes and multiple asymptotes. So I want us to consider this sort of graph this time. Let's start with a relatively simple one. Y equals, let's say 2 over x minus 1. So far so good, we've talked about these, but now I'm going to introduce a second part. So now we have in our denominator a quadratic value, a quadratic equation in x. Still a polynomial, but just a more complicated one. What does that look like when we graph it? Well, we could go through a very big chart of a table of values and then plot them, but I'm just going to show you the result, because I'm just trying to get a concept across to you at the moment. So again, we draw up our graph. This time, we still have an asymptote where x equals 1, because 1 minus 1 would give us 0, and I don't care what that's worth. 0 times that will be 0, and I can't have a 0 on the bottom of a fraction. I can't divide by 0. So x equals 1 will provide me with an asymptote. But I think you can see, because this is a product, we're multiplying these two expressions here, that if x is minus 3, we also get a problem. Minus 3 plus 3 makes this 0. And then I don't care what that is, 0 times that will be 0, and we're trying to divide by 0 again. So x equals minus 3 is also a problem for us. So we've actually now encountered a graph with two asymptotes, two vertical asymptotes. Now, if I move these up here, if I multiply both sides of the equation by this expression, I'd get x minus 1 times x plus 3 times y would equal 2. And here I have a product of 3 terms making 2. That can't be 0, nor can that, and we've discussed that already. But nor can y equal 0, because 0 times those values cannot possibly be 2. So y equals 0 is our third asymptote for this graph, which also happens to be horizontal. Now, where do we graph it? Well, there's a principle that I want to introduce here, that when we have vertical and horizontal asymptotes, we'll learn later we can have oblique asymptotes, but when they're all vertical and horizontal, if we have a positive number here, and by the way that means that we're using positive coefficients of x and y, if we end up with a positive constant here, then the first part of our graph will be on the top right, where we have positive values of x and positive values of y. Now, unfortunately, the point of closest approach, or the way of drawing a hyperbola, is no longer as simple as just finding values that multiply to make 2. Well, it is simple. Here we need 3 values that multiply to make 2, and that's what complicates it. So we can't just say 1 times 2 and 2 times 1, but we do know that the graph is in here somewhere. To locate points, we would actually have to substitute and calculate. But there is no way this curve can cross this line or cross that line. It will just become asymptotically close there and asymptotically close there, but it cannot cross them. Now, not only do we have the principle that a positive number gives us the graph up here, but normally these graphs are drawn in a kind of checkerboard manner. The next part of this will be in this area. If you can imagine, this is like 6 squares on a chessboard or a checkerboard. The next part of the graph will be here, and it can't escape or can't touch or cross these 3 asymptotes, and it will actually exist in here like this. Sorry, I nearly had that moving away from the asymptote there. And then we move up here, and the third part will be here like that. So that's a slightly more complicated looking equation or looking graph. But that's the effect of having a second term down here. It simply produces a second asymptote. And as long as we understand the principle that positive constants up here have a start here, and then we work in a checkerboard fashion, we can have a lot of fun. Let me go a fair leap from now, or at least take another significant leap from this understanding to produce one more example that I hope you'll enjoy watching. Okay, let's try this one. I'm going to bypass the fractional form and just talk about this. What if we had y minus 1 times y plus 3 times x minus 2 times x plus 4 times x plus 1 equals 3. This is a significantly more complicated equation, but you can see its structure is quite sensible. We have 1, 2, 3, 4, 5 things multiplied to make 3. And what will the graph look like? Well, I hope that you're starting to jump a little bit ahead of me here and anticipate the results. We have an asymptote where y is 1. We have an asymptote where y is negative 3. We have an asymptote where x is plus 2. Where x is minus 4 or negative 4. And where x is negative 1. So asymptotes are very, very easy to produce. Once we have the asymptotes located, and we realise we have a plus y plus x plus x plus x, so all the coefficients are positive, and our constant is positive, we know we're starting in this upper right hand corner. And we're going to have this particular, we're trying to draw this moderately well. We have this part of the graph here, and following our checkerboard pattern, we now got across the diagonal here a little box where we've got to have a bit of the graph, but it can't escape. It can't cross any of those 4 asymptotes. So we actually have a little bit of a bubble in here. If we go down here, we have a little bit of the curve will be in here. And if we go diagonally up, we'll have a bit of it here as well. And diagonally down and diagonally up from this, we'll have a bit of the curve there. And that's the graph. Oh, sorry, diagonally down, there's a bit missing. Here it is. And that is the graph for this. You can see it's not a function. If we draw a vertical line through here, for example, there are 2 parts of the graph on the purple line that would lie on a vertical line. Here, the same thing would apply. So there are many, many places where we would have 2 values and not 1. So it's not a function. It is in fact a relation, but it's kind of quite attractive. But this is how we can have multiple horizontal and multiple horizontal and multiple vertical asymptotes. I hope that's been of use to you, and we're going to explore this a little bit more in a subsequent video, but I think we've covered a lot of territory already. If you've liked the video, then please click the like button, please leave a comment, and by all means subscribe so you can find out about the future videos. And as always, I thank you for watching.